Hello, my fellow programmers. Welcome to a new video. Today we're going to solve the maximum subarray problem on LeetCode. So we will have an array of integers, and our goal is to find the contiguous subarray with the largest sum. A contiguous subarray is an array that is continuous, like this one. -3, 4, -1, and 2 is a contiguous subarray. -2, 1, and -5, 4 is not a contiguous subarray. It is a subarray indeed, but not a contiguous one. Okay, so our goal is to find the contiguous array with the largest sum and return its sum. So let's see this example to have a better understanding. The first approach to have is the brute force approach. And the brute force approach is simply trying to check all the possible contiguous subarrays. For that, we will need a bunch of variables. The first one is the sum variable. The second one is the max variable that will hold our final result. And we will need some pointers, I and G. So I and G will define our contiguous subarray. I will be the beginning, the start of our contiguous subarray, and G will be the end of our contiguous subarray. I'm going to put the indices here to help us. At the beginning, E and G will point to the beginning of my subarray, of my array. And for the moment, I have a contiguous subarray with just one element. Here, sum will be initialized as 0. And then I'm going to add this value to the sum. 5 plus 0 is 5. Then I'm going to compare it with the max. For the moment, the max I don't have any value, so I'm going to put the 5 here. For the moment, my max is 5. After that, I'm going to increment my G to the next element. My new contiguous subarray this time is 5 and 4. I'm going to add the 4 to the 5, and it's equal to 9. Then I'm going to compare it with the max. 9 is greater than 5. I put 9 here in the max. I increment again my G. I put it into the next element. Whoops, didn't meant to do that. The next element. And now I have a contiguous subarray with 3 elements. The beginning is 5, the end is -1. And I add the -1 to the sum. It's 8. 8 is not greater than 9. So I keep my 9 here. Then I increment again the G to the next element, that is 7. 7, I add it to the 8, it's 15. 15 is greater than 9. I remove my 9 and I put the 15 into the max. Again, I increment the G to the last element. I add 8 to 15 is equal to 23. And the max, I'm going to put into it 23 because 23 is greater than 15. When I finish, now I'm going to increment the I to the next element and reset my G to the beginning with I. This time I'm going to start again from 4 and do the same thing. And I must not forget to put the 0 into the sum. I'm going to repeat the same process until I finish. When I say I finish, until the I and G are here. So this is the brute force approach. And as you may guess, the time complexity would be n squared. Let's code that. Okay, first we will need int max variable that will hold the min value. I believe it's there. And we will need a variable called sum. Then we will need to loop through our elements. We need the second loop, the G, that starts with I. Okay, cool. And then we need to initialize the sum to 0 and reset it each time we are on the next iteration of I. Okay, and then I'm going to add to the sum the nums G each time, and each time I need to check if the sum is greater than the max and put it into the max if it's the case. For that, I'm going to use the math.max to simplify the code. And after I finish, I return the max. Run the code. Works. Run. I'm gonna just add this test case to make sure it's working. Okay, I tried to submit. I don't think it's gonna work because we're gonna have a timeout. Yes, that's what I thought, but it's correct. So time limit exceeded because it's O n square. Can we do better? And the answer is yes, we can do better. Just gonna remove all this and let's try again. Yes. So the second approach is called the Kadani, if I'm not mistaken, the Kadani algorithm, and it's actually really simple. For the sake of simplicity, imagine that we have already this contiguous array, okay? So the sum would be 9 and the maximum would be 9. So we're gonna ask a question. Should we add the -1 to the sum or not? Okay, so to answer that, we're gonna add -1 to the sum. So -1 plus 9 is equal to 8. And 8 is still greater than -1. So that's okay to add the -1 to the sum, because there is a chance that after the -1 there would be a greater value that will help us to increase our sum so that we can compare it with the max and hopefully put it into our max. There is a common mistake thinking that, like for example, to find only a contiguous subarray with the maximum or the large sum, we should just try to take positive values, and that would be incorrect. And this is a counter example. If we take only positive values, we're going to take 5 and 4, that is 9, okay? And we're going to try to take -1, we want to take it, so we're going to take the next contiguous subarray, 7 plus 8, that is the 15. So we have 15, and here we have 9, so we're going to take at the end the 15 as the max. But here, 15 is not the max. The actual max is 23, because we could have took this a negative value and continue our way out. Okay, so that's why taking just negative values won't work. Okay, so here the key of this algorithm is comparing the sum plus the number at the index I and compare it with the nums I. Nums is this array, okay? So if the sum plus the nums I is greater than the nums I itself, we can add it. We can add the nums I to the sum. And if it's not the case, we just take the nums I itself because it's greater. And we can build another contiguous subarray starting from this I. So if it's not that clear, let's try to write the code to have a better understanding. Again, I'm not going to delete it all. I'm just going to delete this part, this part, this part, this part. Okay. I can initialize my sum here to 0. So I need to compare the sum. So if, again, I'm going to use the max to simplify the code. So mat.max sum plus nums I and the nums I. And I put in my sum the greater value between sum plus nums I and nums I itself. And again, I need to make sure that the max has always the maximum value. Okay, so let's try to run the code. It works. We use the example, test examples. It works. We submit the code. It works 1 millisecond. And the time complexity is O of n because we have only one loop. So this is it. Thank you for watching. See you in the next video. Bye.